Hello, good day everyone. Today's video we will solve a problem from differential equation. So this is application of first order differential equation. All right. So here we are. Um, a 45 Newton weight is projected downward with an initial speed of 4.6 meter per second. Now, if the air resistance is proportional to the speed, and if the limiting speed is double the initial speed, find the velocity at the end of 10 seconds. Okay, so let us first illustrate the problem now. Okay, so we will draw a diagram now. So let's say this is the 45 Newton weight now. Okay, so if the problem involved changing speed, or there is a instantaneous acceleration, so that means that we have to apply Newton's second law of motion. Okay. Okay, because it involves the force and then the speeds, no, acceleration and time. Okay, so we have here the weight. Okay, so we have weight equal to 45 Newton, and there is a presence of air resistance. Okay, so if the motion is downward, no, since the object was thrown downward, no, initially, so it will accelerate downward now. That means the air resistance is directed upward. Okay, so this is our F air. Ayan. Okay, so by applying Newton's second law of motion, so by Newton's second law of motion, okay, the summation of forces, okay, in the direction of the motion, no, okay, is positive, no, otherwise negative. Okay, the net force of that is equal to the product of the mass and acceleration. All right. So here, the force that is in the same direction of the motion is the weight. Okay, whereas the resistance is opposite, so minus F air equal to mass and acceleration. Okay. Now, it is stated that our air resistance is proportional to the velocity. So, we have to write that in equation. Okay, so that means our F air, since proportional only to the speed, that means F air is equal to kV. Okay. Now, our equation will become 45 newtons na given weight minus the air resistance is kV. And okay, what is mass? Since the given is weight, so our mass is W over G. Okay, or 45 over 9.81. All right. So 45 over 9.81. Now, as you can see, the expressions on the left side of the equation is a function of v. So that means now our acceleration should be also in terms of, or a function of f and t. Okay, so the expression for a in terms of v and t is dv dt. Acceleration, now remember, is the derivative of velocity. Okay, now before we solve the differential equation, so this one is a first order differential equation. Okay, we must look first now for the value of k. Now, it is easy now to solve the value of k first. Why? Since it is stated, okay, that the limiting speed is double of the initial speed. Okay, as stated, our initial speed is VO is 4.6 meter per second downward now. Okay, and when you say limiting speed, so after a long time, no, so as t okay becomes large, now our b will becomes our v, or the v limit, okay, is twice of that initial speed, or two times of 4.6 meter per second, so that is 9.2 meter per second. Okay, and then um when the object now is traveling at its limiting speed, so that means the object is moving at constant speed. Okay, by that we can say that the acceleration of the object, okay, is what? At constant speed, the acceleration is 0. All right. So now we can now solve the value of k. Okay, by substituting the given values. No. So ayan, 45 minus k. Our b is the v limit. So that is 9.2. Okay, equal to 45. Okay, over 9.81 times 0. Okay, so obviously the right side will become 0. Okay, then we can now solve for the value of k. So obviously our k is 45 over 9.2. Okay, then bring back the value of k to our equation. Okay, so we will get what? 45 minus, okay, 45 over 9.2 equal to 45 over 9.81 times dv dt. Okay. As you can see now, we can factor out 45, or we can just multiply both sides by 1 over 45. So it simply gives us the new equation, 1 minus 1. No, I forgot to write the v here. So 1 or v over 9.2 equal to 1 over 9.81, then dv dt. Okay, so this one, okay, if you notice, okay, it gives us a variable separable differential equation. So by writing the equation, okay, we will have the equation dv over 1 minus b over 9.2 equal to 9.81 times dt na. All right. So now, we can now solve the equation by integrating both sides. Okay, take note that the left side na, okay, it gives us an expression of in terms of natural log na. Okay, remember the derivative of ln u is du over u. Okay, so you have just to check now if the derivative of this denominator is in the numerator. Okay, so to check that, now you will get the derivative of 1 minus b over 9.2. So that is negative db over 9.2. So to neutralize um um this integral, now we need this factor here, now yung negative 1 over 9.2. Okay, so we need a factor of negative 1 over 9.2. So to neutralize that, now we will multiply the integral by negative 9.2. Okay, then integrating, so we will get negative 9.2. Okay, the natural log, okay, of 1 minus b over 9.2 equal to the integral of this. So obviously that is 9.81 t. Okay, plus the constant of integration. Okay, then divide both sides by negative 9.2. Okay, so here we are na. Will become ln of 1 minus v over 9.2 equal to negative 9.81 t over 9.2. Okay, plus c over negative 9.2 is still, okay, a constant na. Okay, so we rewrite the equation since we have a natural log here. Now we can write the equation into exponential na. So it will become 1 minus b over 9.2, yan, e raised to negative, just copy that na, 1t over 9.2 plus c. Okay, we have sum of terms in the exponent, so we can separate that, and we can write that as c e raised to negative 9.81 t over 9.2. Okay, and then transpose this expression on the left, and this expression on the right, and then flip. So you will get v over 9.2 is equal to 1 minus c e raised to negative 9.81 t over 9.2. Then multiply both sides by, okay, uh-huh, by 9.2. Ayan, so times 9.2, we will get v is equal to quantity, ayan, 1 minus c e raised to negative 9.81 t over 9.2. Okay. To solve for c, no, we will use the initial condition. Okay. At t equal to 0 initially, so our v sub o is equal to 4.6. Okay. All right. So 4.6 is equal to 9.2. Quantity 1 minus c e raised to, if t is 0, so 0, and then e raised to 0 is positive 1. Okay, so that means na our c here is equal to what? 4.6 over 9.2 is 1 half, then 1 minus 1 half is 1 half, so c is 1 half. Okay, so therefore our expression for the v at any time is 9.2, then 1 minus e raised to 1 minus c, so c is 1 half. Okay, 1 half, and then e raised to negative 9.81 t over 9.2. Okay, then okay, what's the required? Okay, we need to find the velocity at the end of 10 seconds, so we just substitute now. Okay, so when t is 10, so what is v? Okay, so just substitute the given value of t. V is equal to 9.2, 1 minus 1 half e raised to negative 9.81 times 10 over 9.2. Okay, then use the calculator. So okay, 9.2, and 1 minus 1 half or point 0.5, then e negative 9.81, okay, times 10 over 9.2. Okay, so we will get approximately 9.2. Okay, so as you notice now, our speed at the end of 10 seconds is approximately, okay, equal to the limiting speed. Okay, yan. So 9.2 is what letter? Okay, letter B. All right, so our answer, or the speed, I mean velocity after 10 seconds is 9.2 meter per second, is and is approximately equal to the limiting velocity. Okay, so that's it. I hope you learned something from this video, and thank you for watching. Right, goodbye.